Hello students, welcome to the Turito School Foundation program. Today we are going to deal the very important topic, that is the problems related to the equations of motion. Just you have to see for the 8th class students. Okay, we would like to go for that animated and well crafted videos, and the modern teaching methods have been applied for these classes. Okay, let's have a look. Just you can go for that. Problems related to equations of motion, just you have to see. While you are talking about that equations of motion, in order to describe that the motion of a body along one dimension, so initially you would like to go for that 1D motion, then you can go for that 2D, that is nothing but motion in one plane. After that you can have the session motion in 3D. It's okay. Right, we would like to go for that uniform acceleration, which is going to be accelerated with that. We are having that 4 equations. Okay, right, let's go for that. We are going to talk about that distance and displacement, yeah, which is going to be identified with the help of this. Yes. In case of one dimension motion, distance and displacement both are going to be same. If the motion of your body is going to be along one dimension, then you will confirm the displacement and distance both are having the same magnitude. At the same time, we would like to talk about that displacement is related to velocity, distance covered by that body. It is going to related to speed. So in 1D, just you have to see, in case of 1D motion, just we have to see displacement that is and distance covered both are going to be the same. So we are going to talk about that vertical displacement. It is clear, we would like to go for this. It is very clear, we would like to go for that vertical displacement. We have to take this one. All right. Okay, we would like to go for that. We can talk about that height also along y-axis. It is nothing but 1D motion. It's going to be the height, right? Very clear. So we can consider the magnitude of velocity and magnitude of speed are going to be same. Velocity and speed are same. Speed are same. It's very clear, we would like to go for that. Okay, here we can apply that equations of motion to solve the problem, whatever that given problem related to 1D. You have the set of equations that are V is equal to U plus AT. Yeah. At the same time, you can confirm the distance covered. Yeah, it's going to be S is equal to UT plus half AT square. It's very clear. And also we are having that V square minus U square is equal to 2AS. And also we are having that in the nth second, in a particular second, does the distance covered by that body, it's going to be S is equal to U plus A by 2 into 2n minus 1. Just we have to take this one. It's very clear. N in nth second, just we have to confirm this one. So these kind of problems are going to be taken, that is S1 we are having, S2, S3, distance traveled by the body. Just you have to look into that matter, it's very clear. all right, in t1 second, all right, t2 seconds, all right, in t3 seconds also. It's very clear. We would like to talk about this one, that is S1 is equal to u t1 plus half a t1 square. We would like to go for this one. This is very clear, right? So we can go for this one, t2 plus 1 by 2 a t2 square. Yeah, we can go for that. Yes, that is u t3 plus 1 by 2 a t3 square. We can have that. Yes, distance covered by that body at different time intervals, just we have to take it. So we would like to go for this one. This is S1 plus S2, which has given that T1 plus T2 in the time interval of T1 plus T2. Okay, it's very clear. We would like to go for this one. This is S2 plus S3. We can have that T2 plus T3. So in the last second, it has been covered the distance, let it be h1. Okay, now we can easily solve the problem related to that. Yes, we would like to go for that. Yes, if it has been covered the distance in the last second, it's going to be h1. Then we can calculate this h1 with the help of the equation of motion. That is very clear. We would like to go for that h1 is equal to u t minus 1 plus 1 by 2 a into t minus 1 whole square. We can get that. So if you know the distance, that is vertical distance traveled by that body at any instant of the time in the last second, then only you will estimate the total height. Is it possible or not? Say yes or no. Yes, you will get that h is the total height. So you can easily find out that h is equal to ut plus half at square. Now if you know that h u into t minus 1 plus 1 by 2 a into, just we have to see, this is the clear, very clear. You will get that into t minus 1 whole square. That's very clear. h1, this is going to be calculated. In this way we can do the problems. Yeah, that is going to be h minus, yeah, that you will get this one. Say, yeah, we are going to solve the problems based on the equations of motions. Let's have a look. Okay, so everyone has to look into that matter. You can go for that problems. Yeah, that is going to be identified. Okay, let us have the session to get the problems. Yeah, a ball released from a height falls 5 meters in 1 second. In 4 seconds it's fall. Just you have to take that. Yeah, you can take this problem easily. We can solve that, which has been released from height, falls 5 meters in 1 second. Okay, just you have to take this one. We would like to go for this. Yes. Right, you will get that S is equal to ut plus half at square. This is very simple problem. You will get that. That is, they have given in 1 second it's going to be 5 meters. In 4 seconds it's going to be 20 meters. Just you have to take that. S is equal to 4. So we would like to go for this one. That is 1 by 2 into 10 into force square. Just we would like to go for this one. This is very clear. We would like to get this one 80. Just you have to take this one. So you can get that. Right. Everyone has to look into that matter. Please have the look. Just you have to observe that and identify the distance which is going to be identified. That is very clear. We can get that. We have to consider that G sometimes it's going to be it's going to be 80 answer. We have to consider that G is going to be 10 meter per second. It's very clear. 10 meter per second square. What we have done. Okay. We would like to go for that next problem. Yes. Yes, it is very clear. We would like to discuss about these kind of the problems. Okay. A ball is dropped downwards. All right. After 1 second, another ball is dropped downwards from the same point. Okay. What is the distance between them after 3 seconds? You have to take that. So, you can take that one ball which is released. It will reach the ground. Yes. So, you will take that 3 seconds. It has been reached that. Another ball is dropped downwards from the same point after 1 second. Just you have to take that. It's going to be getting that. We have to see. Yeah, we'd like to go for this. Right. This is after 1 second. 1 second. Okay, we are going to get that. This is going to be traveled. That is t minus 1 second. That is equal to 3 minus 1. 2 seconds. It has that 2 seconds. It has reached the ground. Yeah. From the same point. What is the distance between them after 3 seconds? Yes, okay. Let it be considered. First, we would like to take that one ball has been released. What is the total time taken to reach the ground? It's going to be 3 seconds. It's very clear. After 1 second, another ball is dropped downwards. It's very clear. Same point. What is the distance between them? Okay, let's assume these are going to be here. Yes, it's very clear. It has been there, right? Now you would like to go for this one. Yes. You have to estimate that distance between them. That is very important. Let's have the look. Okay, everyone has to follow this one. The general equation, that is S is equal to ut plus half at square. It's very clear. You would like to go for this one. But they have not given that initial velocity. It has been dropped from the, yeah, it is allowed to drop down. Okay, it's very clear. We would like to consider that in 3 seconds, the first ball has been, the first ball traveled the distance. Yes, we would like to go for this one. That is, yeah, that is S3 is equal to, let's assume, that is 0. Initial velocity is going to be 0. That's going to be 1 into, yeah, we can take that 10 and 3 square, that is going to be 5. Yeah, we would like to get this one 45. Okay, it's very clear. It has covered that 45. Just let's have the look into that matter. We would like to go for this one. It's very clear. We would like to go for that. Right. We have to calculate that in 3 seconds it has been covered the distance. Let it be h3. Okay, let us assume h3. Very clear. Okay, now you can confirm that h3 is equal to, it has been dropped from that rest position. We have to consider its initial velocity is going to be 0. That is going to be 0 into t plus 1 by 2 into 10 into 3 square. That is 5 into 3 square. That is 5 into 9, 45 meter. It's okay. All right. It's very clear. It has been covered that h2 in 2 seconds. After 1 second means there is a time duration, there is a time gap between the first drop and the second one. That is going to be identified. So h2 is equal to ut plus half gt square. You have to get this one. That is going to be 0 plus 1 by 2 into 10 into 2 square. Very clear. So 5 into 4, that is going to be 20. Easily we can go for that options. Let's go for this is h2. What they are going to ask you, what is the distance between them after 3 seconds? First they have, one ball has been dropped. After another second, another ball is also dropped. But here you would like to know about that after 3 seconds you have to calculate that distance between them. That is going to be, this is going to be h2, this is going to be h1. That is nothing but vertical distance or vertical displacement which is covered by that body, right? After 3 seconds you have to calculate, that is nothing but h3 minus h2. It's going to be, after 3 seconds, the distance between these two balls is going to be 45 meter minus 20 meter. That's going to be 25 meter. It's very clear. You can get this one, right? Everybody has to look into that matter, right? Please note down. And we would like to go for that next one also. Yes, you are all supposed to be here to note down. Yeah, even after 5 seconds, after n seconds also, you can get that. You have to take that after n seconds, how it is confirmed. That is going to be hn minus 1. Yes, are you getting this point? You have to take that hn. It's going to be the vertical distance, that is height, hn. So hn minus 1, you have to get that subtraction. So what's the distance between these two balls after n seconds? You have to get hn minus, just you have to take this one. This is very important for you. This is going to be hn minus 1. If you want to get that, h is equal to ut plus half gt square. Yeah, hn. Just you have to get that. In the place of t, just you have to get that t is equal to n, and t is equal to n minus 1. We have to get that hn minus 1. Yeah, we can do the problems, whatever. So you can frame the problem and get the solve. It's okay. Right, let's go for another one. Very clear. But you have to know that the relation, if they have given the h, the vertical distance which is going to be covered by that body in a given time interval, then you can easily estimate the total height also. Alright, okay. Let's have the look into that matter. You have to get this one. Two trains are each 50-meter long, moving parallel towards each other. Okay, it's very clear. At speeds 10 meter per second and 15 meter per second respectively. It's alright. After what time will they pass each other? This is very important question. Just you have to take that. Here, especially while you are discussing the train problems, you are having that two cases. Generally, they are giving you two cases. First one, you have to take the case. One train, it crosses the another one. Alright. Okay. One train which is overtakes another one. Overtaking and crossing. Just you have to look into that matter. We would like to go for this. This is the case we would like to go. Yeah, it's going to be moving. And also we have to get this one. This is going to be A and B. Okay. Yeah, which is going to be overtakes. In this case, we would like to take the total distance. Covered by B. Just that is going to be length of A, length of train A. Suppose they have given in time interval, in the time of 5 seconds or 10 seconds, they have given the limited time. In that time it has been crossed. The time taken by the second train to cross the first one is going to be suppose 5 seconds or 6 seconds. And they are going to have the speeds also, their own speeds. In order to overcome, they have to accelerate, and at the time you will solve the problem considering the relative velocity. It's very important for you. Length of train B and length of train B. It's very clear. We would like to go for this one. It's very easy for you. Now you are going to get that relative velocity. We have to take that relative velocity. It is very important. So that is VR is equal to VA plus VB plus or minus VB. Generally we are going to take that VR is equal to VA plus or minus VB. If both are going to be in the same, it is going to be case overtaking. They are going to move in the same direction. In that time we would like to go for that VA minus VB. It's very clear. Yes, they are going to be crossing each other. Just you have to take this one. Yes, yeah, it's going to be in this direction. It is going to be. In this case, VR is equal to VA plus VB. Yes, we have to take these two. Just you have to take that. It's very clear. But they have given crossing each other. Just they will meet and they are crossing each other. In that case also we are going to get that length is equal to train A plus train B. Length of the train A and train B. It's very clear. Sometimes you need to take that it is going to be accelerating, it's going to be decelerating. So first train is going to be having that acceleration. So second train is going to be having that deceleration. Let's assume it's going to be the negative sign, it indicates that. So you will take that S is equal to ut plus half at square. We have to take this one. So S Sy Sx, that is going to be ut minus half at square. It's very clear. If they will meet at one point time taken, you can calculate, that is, yeah, you will get that this is x and this is x minus, this is going to be p minus x, total distance is going to be p. So we are going to frame that n number of problems, yeah, based on the train and its motion. But you have to take that they are moving along parallel towards each other. Yes, you have to take the case towards each other means they are going to be parallel but towards each other. You have to consider this case. All right. Okay. It's clear. We are going to having the problems that are going to be true. There are two trains are there, which is accelerating, and another one is also moving. It is going to having the deceleration or acceleration, whatever it may be. If they will apart from that a finite distance, they have been started at the same time, where they will meet. You have to take that they will meet at a one point P. Just up to that extent you have to divide and you have to apply that equation of motion. Easily you will solve that. That is the very important. Okay, let's have the look into the matter. Two trains are 50-meter long and moving parallel. It's very clear. They are moving parallel. Okay, it's very clear. We would like to go for this one, crossing each other. What they have given, moving parallel towards each other. It's very clear. This is going to be A and B. Yeah, they are having the speed. So, relative speed. We have to take that. That's going to be VA plus VB. It's very clear. That is going to be 10 meter per second plus 15 meter per second. It's very clear. We would like to go for that. Okay. It's going to be VR. After what time they will pass each other? Very good. Yeah. So, we would like to go for this one, and also we would like to get this one. Suppose they are going to be crossing each other. Yeah, we have to take this one. This is A and B. If you know that total distance, it's going to be D. Okay, all right. Yes, they have given you the length of each train. Total distance covered, it's going to be distance. That is going to be 50 plus 50 meter. It's very clear. So, total distance D is equal to 50 plus 50 meter. It's okay, 100 meter. Very clear. So, VR is equal to relative velocity, that is equal to, we would like to go for this one. Everyone has to look into that matter. We have to take, that is going to be 25 meter per second. Yes, they are crossing each other. It's very simple. Let us assume, depending on the speed of B which has been crossed, you can take that 15 meter per second. The train B is going to be crossed the train A. So, in order to get that crossing, it has to travel that 100 meters. Simply, it is the time taken by the train B to travel the 100 meters. Yes or no? At that time only it is going to be considered crossing time. Just you have to look. So, you know, VR is equal to D by T. So, T is equal to D by VR. Very simple problem, but it's going to be discussed a lot. Total distance, D total. We have to get that total distance travel. That is going to be 100 whole upon. What about VR? It's going to be 25 meter per second. It's going to be meter. It's going to be 4 seconds, I hope so. Let's see that. Yeah, very clear. We would like to go for that. Yes, everyone has to identify this one. So, you are going to have that look into that matter. We would like to go for this one. Yeah, we would like to go for that. Yes, you can take that time taken. that is going to be pass each other. T is equal to d by VR, that is going to be 100 by 25 meter per second. It's going to be second, it's going to be meter. Yes, we would like to go for that. Yes, so 4 seconds. Let's have what's going to be the correct answer. Please note down that it's very clear. Everybody has to look into that matter. If you are going to look into that matter, just you can solve the problem. What the case they have given you, crossing each other or moving towards, moving in the same direction, overtakes. These are all very important model problems. Let's have a look. So you can easily solve the problems, right? Okay, let's go for another one. Yes, they have given you. Yeah, what is the distance traveled by a body thrown vertically upward direction with a speed of 20 meter per second under the effect of gravity in the first second of its motion? Just you have to solve this problem. Okay, let's have a look into that matter. We would like to go for that. Okay, yeah, if they have considered that G is equal to 10 meter per second, just you have to see. Okay, right. It's going to be having that thrown vertically upwards, the body which is going to be thrown vertically upwards. Yeah. Upwards. Just we have to get this one. What about that u is equal to 20 meter per second? It's very clear. All right. Okay. Yeah. If it is going to be having that time, yeah, in this case, let us assume t1 second, right? That is going to be 1 second. In 1 second, it has been covered the distance. This is going to be like that. We would like to apply that formula. Just you have to get that S is equal to ut plus half at square. It's very clear. We would like to go for this one. Then you can have that. You can have the substitution and get the calculations better. You have to go for that. That is 20 into 1 minus, yeah, you can take that 1 by 2 into minus G into 1 square. We are getting that. Okay, you can get that while it has been projected vertically upwards, thrown up, you have to take that A is equal to minus G. It's very clear. We are going to consider this one, right? Therefore, minus 1 by 2 into 10 meter per second square. It's going to be getting, right, that is 20 minus 5. That is 15 meter. All right. In this way, we can solve the problem. Yes, everyone has to look into that matter. You have to go for that. Yes, what are the options? A, B, C they have given. You will get that A, B, C and solve the problem. It's clear, you can go for that. Yes, first one is the answer. It's very easy for you, just you can apply that. If they have given to get the G, to consider the G value, that is going to be the 10 meter per second square, it's okay. Sometimes you, if they have not given, you have to consider that is going to be the 9.8. Yeah, we have to consider G is equal to 9.8 meter per second square. Okay, we will take this value and solve that. Now we will get that. That is S is equal to 20 into 1 minus 1 by 2 into 9.8 into, we can go for that 1 square. Yeah, that is going to be 20 minus 4.9. We would like to get this one. Yes, it is going to be 15.1 meter. Okay, So if they have given that G value, you can go for that, it's easy for you, alright. Otherwise you can go for that standard value, right. Thank you. Let's go for another one, it's very simple and easy problem. Velocity of a body moving with a uniform acceleration 2 meter per second square, it's very clear, is 10 meter per second, it's okay. Its velocity after an interval of 4 seconds, it's very clear. Yeah, you know very well about that. Uniform acceleration, just you have to get that uniform acceleration. It's very clear. Okay. Yes, you can get the 2 meter per second square. They have given uniform acceleration, that is going to be 2 meter per second square. Very clear. Yeah, what about that velocity they have given you? Velocity, that is going to be 10 meter per second. Yes, then its velocity after an interval of 4 seconds. Just you have to apply this one. This is the basic model problem, we can apply this one, that is going to be V minus U by T, just you have to take this one. Yes, we have to take is equal to A. Okay, V minus U by A, sorry, I would like to go for this one. Yeah, this is the basic relation, okay. You know very well about that. This is going to be U, so this is going to be V, that is equal to question mark. So V minus what we are going to getting that 10 by what about T 4, that's going to be 2. Yes, 2 meter per second square, that is going to be 4 seconds, it's going to be meter per second. Okay, all right, you will get that V is equal to 10 plus 8 meter per second. It's very easy for you, that is going to be 18 meter per second. Easily you will solve this problem. Okay, you can get this one. Everybody has to look into that matter which is correct option. From the given value you have to get this one. This is going to be that 18 meter per second. It's very clear. Okay, all right. Yes, it's going to be having that one problem. A bus traveling at a speed 20 meter per second is subjected to a steady deceleration. While you are going to get that, yeah, with respect to the time, just we would like to go for this one. Right. Okay, this is the problem. With respect to the time, its speed is going to be decreased. It is having the deceleration. Okay, it's very clear. So, initial velocity, it's going to be 20 meter per second. Okay. What about deceleration? It's going to be 5 meter per second square. Okay. How long it will take to come to rest? Yeah, time taken by that bus to reach the zero velocity. It's very clear, to come to rest. That is T is equal to question mark. Yes, it's going to be getting that. How long will it take to come to rest? Yeah, if it is rest, we have to consider V is equal to 0. It's very clear. This is going to be U, initial velocity. This is going to be A minus A. Just you have to take that. This is going to be V. So you have to apply that V minus U by A is equal to T. So you can easily find out that 0 minus 20 by 5 meter per second square, that is equal to t. Yeah, you will get that minus. So you can cancel and get that it's going to be 4 seconds. Very easily you will solve the problem. Yes, this is the answer we will get. Okay, please note down this problem, which is very important. If you want, so you can take that screenshot also. Okay students, thank you very much. Have a nice day. We would like to meet in the coming classes.